Hi everyone, I am Rajkamalai. Welcome back to the brand new series of AI product engineering. And in continuation to that, today I'm going to talk about a very important topic which is design. And this is going to be very essential, very important topic for you as a solution architect, as a product manager, as a senior developer, and even as a junior developer nowadays in the age of AI. So if you're someone working on the client projects, right, you are being asked to develop end-to-end system. This is pretty much important. You go through the certain phases where you go and talk to your stakeholder, gather the requirement, right? Be it functional, non-functional, proceed ahead with the capacity planning. Then you go ahead with creating the HLD document, LLD document, API creation, database design, infra design, and so many things. So in order to do these things very efficiently, it is pretty much expected you to know the design core concept. For that, I am going to start our end-to-end system design playlist, which is basically you can refer as a software developer, as a full stack developer, and even as a AI engineer. Okay, so without further delay, let's get started. So guys, Uh, I had just opened my Blackboard. I hope it's visible to everyone. So I'm just going to talk about system design. So before starting the design directly, right? So there is a typical software development life cycle which I believe everyone should know as a software developer, a full stack developer, or as a AI engineer, right? Which is pretty much essential to develop and deliver end-to-end solution to our client. To to understand SDLC, which is nothing but software, which is nothing but software development lifecycle, there are different phases as a part of software development lifecycle. So the first step is come as a planning, planning, and I would say the feasibility analysis. Feasibility analysis. Okay. So guys, here uh, when we get the requirement, right? So mainly here the people like product managers or our stakeholders or senior developers would request for these to and fro discussions. And here we will be doing three things: the project feasibility or use case feasibility study, right? So the project feasibility study, then we'll also, because some, I mean, most of the times clients are very choosy. Client is very demanding. They come up with so many advanced features to be delivered as a part of their requirement, and they are also very much particular about the tech stack that they want to be used as a part of their project development, application development, right? So we need to also understand the financial or budget. So we'll also be understanding about the financial feasibility, that in the given budget, is it feasible to deliver that sort of client project which is being expected from the client. Then there is a third topic, third study, that we do the operational cost. There we talk about the resources would require in order to develop and deliver this client requirement. So, and as an end of this phase, we get the project plan. These are the document basically, okay? And then we'll get the feasibility report as well. Okay, so this is a very initial step of any software development, any application development. Okay, guys. And as a next step, if I talk about, so there we get the requirement gathering phase. Requirement gathering. Here in the case of the requirement gathering, so there are two very famous terms that I believe everyone would have heard of: the functional requirement, then the non-functional. And I will be discussing this in much detail as a part of system design, as a part of next topic in today's session only. But I'm just giving you a high level overview. Here we will be discussing about what all feature we are going to deliver. Suppose I am going to create a YouTube kind of platform, a mini YouTube platform, right? So what all functionality a client is expecting to be delivered as a part of YouTube application. So he would be expecting that the creator can upload the video, and then the end user, the consumer, can watch the video, then can end user can make the comments or hit the like button or subscribe the channel. These could be the bare minimum functionality of creating a mini YouTube kind of platform, right? So these all things comes under the functional requirement discussion. So this is being documented as a part of to and fro discussions, and it depends upon the scale of project that or the size of project we are delivering, because depending upon the size of the or complexity of the project, we may require spend end up spending so much of the time, right? It could be 1 month, even the quarter in the case of the big projects we spend for the requirement gathering. Okay, so that is this is how generally things happens in the real world. For the non-functional requirement gathering, so their client could say, suppose we are starting our business with 1,000 users today, right? What if my user base increases from 1,000 to 10,000 users? Is my system is able to cater or serve these many users? If not, so this is of no use for the user, because this is a part of the requirement gathering where client is saying just create a scalable application which can take load from 1,000 user to the 10,000 users, because there will be the peak season for every business. It could be the Black Friday, it could be Christmas, New Year, anywhere, Diwali, Holi, even for us, right? So the the network traffic will increase. So in that case, will my system is able to cater those request user requests or not? So this comes under the scalability. And guys, this is the non-functional features, right, that we talk about as a part of non-functional requirement gathering. So again, there are many terms like reliability, we'll be talking about availability, we will be availability we'll be talking about. Then there is a topic like maintainability, maintainability, then performance, then security. These could be the topics that we can talk about as a part of non-functional requirement gathering. And if I'll give you the one liner, scalability, you know, the reliability, how reliable the responses are we sending the duplicate records? No, right? So those things we will be ensuring from our side as a part of this availability. So there are a concept of like 99% system availability. I mean, if you're designing a application, so what is the guarantee that in how many days out of 365 days this system will be up and running? So that kind of agreement happens between you and the client, right? And it increases. This is a bare minimum. Talk about there is a 99.9% available system. Then at higher end system are like 5 times 9. Okay, only 5 minute I believe in a whole year, that it can be down. For rest of the whole year it will be up and running, and that is very difficult task, I would say. I mean, to maintain a system with only 5 minutes of the downtime, but I mean, that's how the things are. Okay, so these things we covers a part of availability, that have we agreed on 99% availability or 99.9% availability, or it is a 5 9. That's again very subjective things, right? Then again, the maintainability. If some there will be features as a part of your application, what if the new features client is asking to integrate, right? So how many effort we would require in order to integrate that features, uh, how efficiently we can do it, right? Without making, it's not like that making a single changes, we are doing so many changes in the whole code basis. It should be very modularized in such a manner that maintainability is very easier. Then we will be talking about the performance, right? So how can we make a system more performant in terms of adding more cache, in terms of the low latency, all those things, and security using the firewall, and IAM role, and many more things. So all those things we will be discussing or gathering those requirements as a part of non-functional requirement. All right, guys. Coming to the third point, which is talking about which will be talking about design. So basically, as a part of system design, design is a phase where we will be talking about the system design, but there are so many things come under as a part of system design. So for that, after explaining this software development life cycle, I will be covering those things, because there are 7 core pillars that I need to discuss, so that you can understand the end-to-end flow of that. So after design, we'll start with the development. Development. Once the development is done, suppose as a complete application, right? So it will be having back end, front end, AI services, then it will be some DB services, and then the catchy services, right? So like we have talked about this architecture, and we understand in detail, right, the part of Docker playlist. So it could be backend service and could be front end service, and there will be some AI service. This could be the DB service running a different container, and then it is the cache service, right? And this is the nginx server for reverse proxy manager. So in order to develop the application, develop the product, you will be developing the front end, you will be working on developing the back end on the related endpoints, then the DB related development, then cache related development, then AI system related development. Each and everything we will be completing, right? And ensuring the best coding practices are followed, right? So that is the whole idea. Coming to the fifth step, which is nothing but a testing phase. So here we test our system end to end, start with functional testing, unit testing, functional testing. Then we talk about the integrations testing as a whole, right? Each and every module we tested as a part of here. Each uh, I mean, this is a test cases. It's related to functional testing only, right? Where each functionality level testing we will be completing. Then as a part of integration testing, we will be testing it as a whole and see as a system that how these module all together are working. Are they working as expected or not? So this is the integration testing. Okay, then there is a topic like system testing. Then there are things like performance testing, or the load testing, I would say, with the huge traffic, right? So we develop our application, let's say, with considering 1,000 user in our mind, right? And now your system is working as expected. What about if the traffic increases from 1K to 10K users, right? So with that load, is your system working as expected or not? All those things, the testing related aspects will be covered as a part of and tested the whole system end to end, right? Ensuring that system is working as expected. And as I think as a part of this testing phase, you will be end up creating those test cases file or documents. Okay, and then if you're talking about the next phase after testing, we'll be deployment. So like whatever the Docker container concept we have learned previously, it will come to rescue you in order to create a production grade end-to-end system. Then there are a CI/CD workflow automation. So these topics will be covered as a part of this deployment. Okay, and so as a part of seventh topic, so here this is comes as a maintenance. Okay, and under maintenance, basically we'll talk about the bugs. I mean, the system which is already live, right? So as a ops team, you might be observing in your company as well. People as part of ops team, they keep on monitoring the application health. So there could be some bug uh, they will find in the production system in the live application. So if it is reported by end user, you will be documenting and start working on it. Then there will be some minor enhancement with some small development effort, right? And then there will be monitoring. So at high level, this all things comes under this part of software development life cycle. Okay, these things are pretty much important for to give you a gist about the end-to-end development life cycle, right? So there are certain steps that we are following. It's not that we are getting the requirement and then we start building it directly, right? That is not the whole idea. That is the whole idea of making this video as well, to make you understand. If you get the requirement, right, you would be having so many questions in your mind, right? Just get it clarified, get those answer first from your stakeholder. Try to understand the stakeholder expectation, the current business constraint, budget, risk, each and everything. You have to document it. When everything is freezed, now as a next step, you go ahead and do the development, test, deploy it, maintain it going forward, right? So in monitoring as well, there are Grafana, Prometheus, different tools that you can be used for the monitoring automation. Okay, all right. So let's understand system design, guys, which is the core idea, and which is the primary objective of this video as well. But I thought before directly jumping to the system design topic, it will be great if I can give you the quick walkthrough about how the software development in the industry great project works. Okay, let's talk about the system design. So here again, I will start with requirement gathering itself, because generally it comes under the requirement and the system design itself. Okay, though we are maintaining those blocks, building blocks, are part of SDLC lifecycle, but this is pretty much practically when you're working on the project, the requirement gathering phase will comes a part of system design only. Okay, system requirement gathering. So in the requirement gathering, as I mentioned, there are two topics: a functional. There will be two type of the requirement: functional requirements, the non-functional. Let's discuss about the functional. Okay, so I have given you the walkthrough, but let's understand in detail. So I have just prepared this beautifully a beautiful documented document with real-time examples, so that it will be easier for you to relate each and everything. Okay, so guys, if you see here, as a part of functional requirement, the main objective of the functional requirement is what it tells: what should the system do, what is the basic functionality of the system in the layman language, right? So suppose I have given the example to create a YouTube like a platform. The functional requirement could be like user can upload the video. So in order to give you complete understanding, so as a content creator, right, whatever the things I'm recording here, this is the one lecture, right? And in order to publish it on the YouTube, what I will do as a content creator, I will record that session and I will go to the YouTube website, and there from with the help of this YouTube studio, I'll go and upload the video. Okay, this 180p pixel or 720 MB file of 10 to 11 or 10 to 15 minute video, whatever I have recorded, I am going to upload this on the YouTube. So this is the bare minimum functionality that we are expecting as a part of YouTube platform. So I will be uploading this videos. This is one of the functionality. Then user can watch. So I am a creator. I'm acting as a creator, and there will be the huge population, the world, who are watching my system design playlist. So what they are doing, they will be opening the browser and just going to the YouTube application and then search for that video, and they will, if they find it relevant, useful, they will be watching it, right? So this is a, one of the functionality that the consumer the consumers will be doing. They will be watching the video. This is the one of the functionality. Then user can like and comment on the video. This is the very real thing, right? If you like the content, definitely you are going to like it. Definitely you're going to subscribe it, right? Or putting some motivational comment on top of that as well, right? So these are the user interaction which is going to happen as a part of bigger minimum functionality of YouTube application. Okay, so and there will be the functionality like subscribing to the channel, then search for the video, and as a user you can go and search for the any video. If you are very much interested in the system design related content on the YouTube, you can go there and start searching for the system design for the AI system development, and my video will be popped up and you started watching it and exploring it. If you like it, you will hit the like button, you'll subscribing it, and you will be posting the motivational comment as well, right? So these are the bare minimum functionality which is expected from a YouTube kind of platform. So this comes under the functional requirement. But see the impact of this functional requirement on the system architecture. Whatever the end-to-end system I'm going to design, there will be the impact of this functional requirement. Let's understand. Let's break it down step by step. See the services I'm talking about: upload services, video services, comment services, search services, right? We will be creating the separate services for this functionality, for these components, right, in a microservice based architecture. Okay, So these are the services, and there will the endpoint will be creating at the code level. So when the user can requirement is like user can subscribe to the channel. For these things, it will lead to the request that will be the post type with slash subscribe endpoint. So in this API call, we will be writing all the logics related to the subscribing the channel. Similarly, if someone wants to unsubscribe, there will be the request. I mean, just like a get a post request, we will be using delete a request underneath for this endpoint. And at this endpoint or this route, we will be writing the logic related to that. Similarly, for the get, so for the subscription, we will be using the get request. And under this route, we will be writing the logic for the subscription, right? So see, this functional requirement of creating these services are underneath triggering creating they are triggering the need of creating these API, these endpoints. That is pretty much important that you need to understand. Just try to connect each and every dot, guys. That is pretty much important. I mean, doing something is triggering something else, right? So if you are able to connect those dot, you will be end up creating a robust end-to-end system as per the client requirement. That's the whole idea. If you are doing something, their data is involved, right? So we'll be doing the database design as well. So when we are saying the requirement is user can comment on the video, when your client will be saying as a part of requirement gathering connects that user can comment on the videos as a part of primary functionality. So what it does in terms of the interaction between the DB tables, so we will be directly, I mean, it will trigger the thought process of thinking the underneath tables that there will be some user table, there will be some video table, there will be some comment table. Okay, then how these are related to each and other, right? Similarly, in terms of the business logics, so it again depends on business to business. It is customized to the business is specific. So they are saying only video owner can delete their videos, right? That is a very genuine ask, right? Otherwise, anyone, after uploading the videos, anyone will come and delete my the system design playlist, right? It should not happen like that. The control should give to the owner. So for that, if that is the requirement, it is leading to the rule authorization. So there are different services altogether apart from this basic functionality of the application. There are many related services that we need to think upon as well, right? Like authorization logic, we need to authorize the user that that is the owner or not, then only he or she can delete. Similarly, the ownership validation, then the permission, IAM role, all those steps, right? Then talking about the user workflow. So client will be explaining that what should be the flow of the application. Ideally, he wants, I mean, as a part of the user can upload a video, so there should be like suppose Raj is the creator creating the system design video. Probably he firstly he need to validate himself in order to log into the system, right? So he will be logging to the YouTube with his credential, with his email ID, something like that, right? And after, he will be selecting those videos from his laptop or some hard disk, right? Then he will be uploading as a part of this video upload in the studio, YouTube studio platform. And then underneath, YouTube will be doing a transcoding activity, right? That is the huge process altogether. I will be discussing in the very new, very fresh video of YouTube capacity planning. There I will be explaining you this transcoding farm in detail, because there are so many things underneath is going on as a part of transcoding, and that will give you the essential understanding how this YouTube system design is working, how efficiently, I mean, developers has managed each and everything, because they are managing around 2 billion population, 2 billion users across the globe, right? So that is not a small thing. So there are many things come into the picture. Then we are going to publish it. So as a part of this requirement gathering phase only, we will get to know from the client that this is the kind of flow you client is expecting. Accordingly, we will be working on creating the front end, back end, DB part, caching part, right? CDN network, so many things will come into the account. But uh, you need to understand what all things could possibly exist as a part of functional requirement discussions. So these are the things, right? Then yeah, then there is another part, integration, right? When the requirement is says, when the client says user should receive the email notification as well, right? So in that case what, we should be setting the some email services, SMTP services, notification services, and these are the external services we need to integrate within our existing application flow, right? To enable this notification service to the client as well, right? So this is pretty much important. Sometimes we, I mean, do not talk about, and we skip this integration requirement as well, and we just dealt into the client related bare minimum requirements. But this is something is very real, right? Again, if we're talking about the security requirement, client can ask about, user can reset the password as well. This is the, I mean, very genuine ask, right? Anybody can forget their password. So it will lead to the external services like authentication services, identity management services, OTP services, right? Which is pretty much popular nowadays. You will be able to relate each and everything, right? And so these are the things, there is so many things, I mean, I have not covered. There's a very bare minimum thing that I'm explaining due to the time constraint, right? But I believe it has given the proper understanding about how the things work underneath, right? Okay, just go down. Let's talk about the non-functional requirement that is also pretty much important. So I am talking about, uh, let me select, okay, this pen. Okay, so here in terms of the non-functional requirement, now on top of the essential functionality, right, we are thinking how well should the system perform. Now on top of that, the functionality is okay. Now with upload functionality, with subscribe functionality, with comment functionality, with watch functionality, what else client is asking? Client is asking, currently uh, I have the 1,000 customer base, but probably 5 year down the line, 2 year down the line, my business will scale and we need to cater the 10,000, or even in the peak season there is a requirement where we have seen the 10,000 users start using our application. How will tackle that situation? So there the concept of scalability come into the picture. Okay, so there are many aspects like performance we will be talking about as a part of non-functional, and it again depends upon the client requirement. So the ask could be like your search results should appear within 20 millisecond, right? So we need to think how this can be, I mean, how we can support this client ask with the use of some catchy system underneath, where we are just their flagship products can be cached, right? Because the 80% of business generally comes from the 20% of products only. So if there is a ask for the product search, and because those things are cached, that could be quickly, I mean, sent to the client search results, right? That's how we can expedite this whole search process. So this is the one of the, I mean, that's giving you one perspective, that's how you can think of the performance perspective, right? In terms of the scalability, I talk about, suppose our system should cater the 10 billion daily active users, right? So is our whatever system we have created, is it capable enough to handle 10 million uh, active users request, right? If not, we need to think upon that, right? Availability contracts, it could be like they're expecting this application should be up and running 99.99% uptime, right? So uh, so for, I mean, if you talk about this uptime, right? So let me go to the browser. See, just try to understand what does it mean. 99.99 availability means what? 99% availability means often called four nines, right? Means a system or service is operational and accessible to users 99.99% of the time. In practice, this limits the maximum allowed downtime to roughly. Now, I mean, if this much availability you're promising or committing to your end user means you can only afford going down for 52.6 minutes. I mean, that is huge in itself, right? Uh, at every month level it's a bare minimum like 4 to 5 minutes downtime at every month level, right? Which is, I mean, pretty much hard to meet, but that's how the protection grade system works, right? You might have seen the Amazon system, the Google system, right? uh, the expectation is too much high. People are expecting to be available all the time, but still the outage happens. So that's where those availability comes in handy. Okay, just going back to the blackboard again. So, and if the customer asks, the sensitive data must be encrypted, those all things will come under the security, right? Suppose the customer PI data, we do not want to expose the outer world. What kind of encryption mechanism we are using as a part of security aspects? So then the reliability, no data loss during the failure. Okay, so how this is how reliable systems should be once you are delivering your end-to-end application to your end client, right? And then in terms of the maintainability, systems would support easy upgrades. Suppose as a part of next release or next maintenance cycle, we are coming up with some minor enhancement, some change request. So it should be easily accommodated in the given architecture. So that's why we generally use microservice based architecture, right? So I will be explaining those concepts. That so many things are planned to come as a part of this end-to-end system design playlist. So guys, just sit tight and just try to understand. Okay guys, so let's understand the impact on the system architecture. So whatever the functional requirement gathering we have done as a part of those stakeholder discussion, understanding the client requirement. So there we already talk about this performance, scalability, and availability things. Let me bring this my pen. Okay, so we talked about this performance, scalability, availability, security, reliability, maintainability. These are the aspects, right, which client will also introduce on top of the bare minimum feature that we have captured as a part of those functional requirement. But see what will the impact of incorporating aspects like the performance or scalability or availability or say security, reliability, or maintainability in your system. So as an impact of that, the architectural changes would be like we need to include the load balancer, we need to include the caching for serving it quickly in milliseconds, right? Or replication would be required in the case of suppose the fault tolerant. I think one of the data server maybe go down. So in the if we have the standard generally we follow at the in the industry, it's like 3x replication. So same data will be replicated, and even in the case of one data center goes down, it's able to serve your user request. So that is the whole idea. Then sharding is one of the database concept where one big database which is now non-performant because lot of user details. And now as a sharding we will be splitting into the smaller dbs, right? And with limited capacity, and then it will have able to cater the all the transaction related request more efficiently. Then there is concept of CDN, basically the content delivery network. That is a pretty much very important thing, I would say, because in general how things happens. Uh, so suppose I have built up one application and I have deployed on the Mumbai location in India, let's say, right? In Mumbai, I have deployed this application. Now, if you are making the request, trying to accessing this application within the India, right? Probably it will go and make the request and get the responses, and it will be quicker when those requests are particularly coming from the Maharashtra only. When at the state level, suppose I'm trying to make this request from the Kerala, from Chennai, and these locations, right, might be the network travel time will increase, and so the response time is so. And as a system, as a I mean, as a business grows, there will be the users from the other continents, other regions, maybe some from the US region, maybe from the European region. They will be making the request to access your applications. So in that scenarios, suppose someone is from the US region or European region, European region, or from for some Asian region, right? They are making the request and trying to access your application. And in that scenario, this network travel time will increase, and even the more bandwidth would be required in order to expedite this request in lesser time. So anyway, anyhow, this is not a scalable solution, right? And even it is not possible to deploy application across the globe, the replica of it application in every region or so, right? So in that context, there is concept of CDN, content delivery network, comes into the picture. What it does, if the request is making getting made from the US region, so for that region there will be a group of the computers or edge machines where the this replica, or I would say the copy of the data will be stored here in this location. Okay, and even if you read about the CDN, so most probably how it works, whatever the static data we have at the app level, application level, be it the suppose CSS related, right, or some images, or it could be some JavaScript related, right, or some text related. So the static data generally we keep on the CDN network on this edge devices only. So it gets replicated over here, and someone, if they are trying to access this application, so in no times, I mean, they will feel like this application is hosted in US region only, and that's how quick this response would be. So similarly, even for the non-dynamic data, right, for making some writes all those things to make it more efficient. So for with respect to every region, so CDN will cater in such a manner that they will be hosted these edge devices, group of computers or machines in particular regions. For the US, this is for, let's say, the European region. Okay, and whoever is trying to accessing with respect to the different regions. So since these information, this is static, or this information are replicated over these edge machines, so it will quickly serve the client request. And even if suppose, I'll just try to give you example of the YouTube so that you will be able to understand in a better manner. So in YouTube, what happens, so generally there are some viral videos, right, which is generally got more traction in every region. So those viral videos which are high in demand, so what YouTube does, it host or it copy in every edge devices, so that wherever suppose this YouTube on the Google data center it's hosted, right, it US in somewhere. So if suppose in the US somewhere, just a minute guys. Okay, US is here. Okay, so the YouTube, suppose this hosted basically in Google data centers. And so what happens, just a minute guys. Yeah, in Google data center, suppose this is hosted, this YouTube, And uh, what it does, it ensure whatever the viral videos are, that it get hosted on every region CDN networks. The underneath it will get copied on the these edge devices only. So these viral videos get copied into these edge devices. And whenever and even for the India as well, for Asian region, suppose there is a CDN maintaining the different, and this viral video also will copied here, right? So as in when even the actual server is hosted on the Google data center placed in US, but if you're making some requests from India, trying to access those viral videos, it will quickly provide those information in no time. So that's how the constraint of the challenges of the network bandwidth, or the even the challenge of the this quick response will be served in a better manner, right? performance Performance is one of the aspects, right? How quickly we are serving to the user need. So that is one aspect. And then apart from let me use the different color. So apart from, there could be some new videos or rare videos, or I mean the video which are not much popular. Okay, initially, suppose you are looking for that video. So what happened, and you are making that request, suppose for this system, for the system design video, which I just newly uploaded, right? Which is not at this point of time, which is not much popular. So what it does, uh, this request, as a request, as per the request of this new system design video, which is rare, what YouTube will do, YouTube will, because these videos are not copied, because these are not very popular videos. So as a I mean, as a pre-activity, user has not copied this data on the every devices. So when we are making the system design video, the new video, the very first time, what YouTube will do, from this main server, they will load once load once in every of the edge devices. Okay, be it Asia region, be it in European region. So this is one time activity that will be slow, precisely in the one first go. But after that, what will happen, since this is cached, or it is stored on their disk, now going forward, if you are trying to hit again, look for the same video, search for the same video from YouTube India, so what you will find, it will able to quickly serve you with that request. Okay, so that's how the CDN underneath work, and it is very pretty much important concept, which comes from the non-functional requirement gathering only, right? And similarly for the message queue, there is a very real-time examples I can tell you for the notification system setup, right? So there are a lot of notification or messages will come to the partitions, to your message queue, and uh, then from the user end, your consumer will be consuming those messages, notification messages from particular partitions, from Kafka cluster or Rabbit queue, message queue cluster. But there could be chances that your end user is fail to uh, fail to consume those messages from the message queue. But in that case also the data will persist there, right? And even so fault tolerant is the one of the aspects that message queue is enabling you with. And then there is scalability concept is also, I mean, even there could be many consumer at the end, suppose what I'm trying to convey, there will be the message queue, right? Suppose we are using Kafka, a preferred one, and there will be different partition, and it will having different messages. And from the end users, suppose your application is trying to consume it, right? And there could be the multiple application as well. So there could be the chances, the first of all, message will come here, it will sit here in this cluster. So as a if somehow app 1 is not able to consume this data, it's fine, still data will persist here, right? So fault tolerance we are able to achieve here. And in case there are 10 different applications trying to consume the same message, in that case also this message queue is able to cater or serve this request in a more scalable manner. So both expect the fault tolerant and the scalability we are covering here. Then monitoring is one of the aspect that comes under the non-functional security. Distributed databases are talking about, right? And even there is a concept of cap theorem will come into the picture to decide the I mean to choose the database meeting consistency and the partition tolerance or availability, or and the partition tolerance. It's again the design choice and the business requirement to meet those kind of requirements. Basically we'll go and choose the distributed database. Then the auto scaling, as and when demand increases, so can scale from 1 to 10 servers, right? So that comes under auto scaling. Then the multi-region architecture to make it more fault tolerant, high available system, right? In suppose in one region, one data center, another region, another data center is available. So in that scenario, what will happen? So even that one of the data centers part of one of the region goes down, still it's able to serve. So the high availability is one of the factor that we can achieve using these things, disaster recovery. Okay, then the rate limiter as well. So there are many things we will be learning as a part of non-functional requirement. It is very straightforward theoretically when we trying to learn this concept, but it is pretty much recommended and advisable from my side that when you're going for the stakeholder discussion with the stakeholder, your client, try to document each and everything, their expectation, the constraint, the budget, the risk, each and everything, so that you can mention that, and the given timeline you can come up with the project plan, the feasibility report, even with the whole development life cycle. You can just imagine and you can draw it, and that's how the things works. Okay, so let me remove it. Okay, that is pretty much fine. So we have covered uh, functional and non-functional requirement. Now let's jump to the blackboard again. Here here I was talking about functional, so that is done, and I have covered non-functional requirements as well. Okay, and then we talk about in terms of the system design. As a next step, there is a capacity planning. That is a pretty much important, guys. In this capacity planning, it's give the projection, the financial wise, the expenditure wise. If you are trying to design a system, right, working certain component, how much cost it will take to deliver end-to-end system. So those aspects we cover as a part of capacity planning. And there we'll be talking in terms of the users, right? Daily active user, I would say, or the monthly active user. There will be some assumption. On the basis of those assumptions only we will be making those calculation. Because they can say there is a 10,000 daily active user, or a monthly there could be 1 lakh active users, or 1 million active users, depending upon we will doing the calculation. So user is one aspect, then how many requests are coming to the hitting to the application, right? Then there will be some network aspects. Then there will be storage aspect. Storage, sorry, spelling mistake. So there are so many things will come under the capacity planning. If I just break it down step by step further, okay, so uh, I will talk about the next phase as well. So if I break it down, so let me give you a quick walkthrough so that just able to connect those dots. So suppose if you are uh, as a those stakeholder discussion, they will be telling you daily active users, right? It's 1 million or how many, right? If you're designing a suppose a rack system, a knowledge base basically, right? How many documents you are going to uh, parse and I mean, using those documents, you will be creating your knowledge base, right? So there could be 1 million document combination of those PDF, Excels, for some HTML non-structural data, right? Then there will be, in terms of the rack system, you will making those queries, right? How many queries per day? Those assumptions, okay. And then queries is okay. And then assumption for document size, one document, there could be some size, right? Some 10 24 MB or something like that. Some of the, for that only you need to do the market research, right? So that is pretty much important, so to get that baseline to start with. Now for one document, how many chunks will be there? So like three chunks if you're taking into the consideration. And then every chunk tokens per chunk, this could be one of the calculation. Then uh, that is fine. Then we will be embedding, right? Embedding tokens, or it could be llm output. Okay, many things. And then llm input cost, llm output cost total, input token cost, llm output cost total, llm cost and cost per query and cost per user per month. That projection, this will give you the idea that after building this application, like application knowledge base, right, when you're giving the licensing to the other user, how much price you can charge, right? So without that estimation, how can you be able to know that this much effort, this much expenditure in terms of the LLM cost, software cost, hardware cost are coming, and after considering each and every aspect, this much we can offer to the end user, right? And then the storage cost, there will be storage cost as well. This much tokens, right, we are storing, because see the embeddings and all those things, right? So the embedding size, so basically like we are using OpenAI LLM, OpenAI embedding, and suppose it is of 1240 dimension, right? Whatever the text we are passing into that embedding uh, model of OpenAI, it will create a vector of that dimension, right? We will be storing further onto the vector DB as well. So there also the storage would be required, right? So those calculation will be also be done as a part of this estimation. So storage cost for the vector DB, let's say, right? Then there is a network bandwidth. So guys, in order to access any application, so there is a particular I mean speed it would require. Suppose in order to hit the internet, Google itself, okay, .com. So it also depends, how quickly this will open on your device depends how optimized or how advanced your device is and your internet speed, right? So again, it's nothing but the network bandwidth you have. So if you have 100 Mbps 1 Gbps, in that case it will quickly this website will be open. In case you're using 2G 3G sort of network bandwidth, it will take so much of time to get it loaded. So that is pretty much also important. Then the CDN calculation, CDN uh, cost. So here uh, generally uh, ideally I would say 98.5% to 99% for this standard production grade system that you look around you, like Google or it's youtube.com. So they provides this much cache hits. These many times the search you are doing, the content is coming from the cache, from the CDN itself, right? This is very real, like for 1.5% of to 1% of time you're looking for a very rare video. For that it go to the uh, your original application hosted on Mumbai or some location and retrieving the information from there to US or all, right? So this is the the industry standard. So considering that, we calculate the seeding cost as well. So see, these are the underneath calculation we are doing. Then again, if we are working on any agentic system, there will be, again, apart from, because here it will be query search, in case of the rack system, agentic system, there will be session, so number of session per users, right? Then there will be concept of tons. So this is the communication between user, pair of message between user and agent. So how many interactions, such interactions are happening. So those assumption will take some numbers. On the basis of that, we do the computation for all those things. Then here there will be the LLM input tokens per day, then LLM again output tokens per day. Then here we'll be talking about the session storage as well, because it will use this input history, right? Those It will be using those historical information to make to use that as a context, a strong context for your LLM to make further response. So guys, try to understand in such a manner. This session response is basically required to keep the your conversational history. And if agent is able to maintain this conversational history as a part of session storage, so it will be easily able to communicate, right, your user in efficient manner without hallucination, because context is retained, right? Now it again matter how much memory we are allocating for this session storage. I mean considering there are two trade-offs, right? We need to also ensure those requests and response are happening very frequently, very efficiently in low time with the low latency. Because if the session storage is going to increase, then again it may impact your uh, response time in millisecond, right? So that we there will be some trade-off around it. But again, without that, agent will highly likely it is going to hallucinate, right? So that is pretty much important. And then there is a concept of this tools calls. Accordingly, we will be here again storage cost. We will be calculating the network bandwidth cost. We will be calculating then the CDN cost. overall uh, overall cost per session, cost per session, then cost per user per month, user. Even we will project it for the yearly and 5 yearly plan, so that because generally when a project is started and we are into discussion with client, so they uh, they give us work um, under the consideration that we are, I mean, we are uh, doing all the required planning, all we are taking all the things into the consideration that this application can sustain in 5 years, because any business to grow, it will take around 2 to 3 or 5 years is the lifetime span that we generally consider at the industry level. So whatever the planning we will be doing, given the 1 year, 5 year, 10 year down the line, so that's the whole idea. So these many things, guys, we are going to do as a part of capacity planning. Okay, and there is a more practical session are coming in future, very frequently, not in future, like in today or tomorrow. I'm going to release where I will be doing the capacity planning for the YouTube live, right? But then capacity planning is done. So I think after that, this is a 4 point, I believe. So many things. No. Okay, requirement gathering, capacity. I think third point. Then we will be doing HLD. Okay, there we will be talking about what all services we are delivering to the client, right? So those things we'll be mentioning, all the components. Then architectural diagram, archi, TECTURAL, architectural diagram. Then architectural diagram, what else? Talking about the data flow, talking about those integration between the different modular or components, integration between different components, right? Suppose this is the video upload service, video upload. This is for, let's say, video watch service. So how this integration is going to happen, all those aspects, right? Going to talk about. Then the DB level things is also going to talk about. Then the wireframe. Wireframe is one of the important thing which includes those user mockups, the application UI mockups, UI screen mockups, and I would say the user journey it captures end to end, right, as part of this wireframe. Then we'll talk about LLD. So these guys, these are the very important document, high level design document basically, and this is the low level. Okay, as a part of here we'll talk about in more granular level. Suppose whatever the component we have talked about in HLD, we'll talk about the business logic underneath and implementation. Business logic. Okay, components fine. Then we'll talk in terms of the classes, objects. Guys, today there is too much writing I've done, right? And then object is fine. Then that through which your diagram through which relationship we will be capturing. Okay, okay, and after that there is a methods. What all methods we are going to more create it, those details will be mentioning here. What else? Yeah, we can talk about some of the data structure here as a data structure. So those graph, tree, linked list, array, those things will be there. But apart from that, because those are primarily building blocks to even create some custom algorithm. Suppose client is looking for some custom search functionality, keyword search kind of, which is the semantic, which could be the distance base, which could be a fuzzy match based, right? So to implement or write the custom logic for this algorithm, which is the which is business specific. Okay, so we will be using those data structure to develop this algorithm as well. So those discussion we will be mentioning as a part of low level design document. Then this LLD is done. Okay, so once this LLD is done, we'll talk about the database design aspect. There we'll talking about those data models like the customer order, product tables, right? And this object model and the relationship, ER diagram, logical physical relationship between them, right? Like one to one, one to many relationship, all those aspects of related to data will be covering here. Then the schema related DB related information or those data type, everything, and even the data, right? DB. Then yeah, I think this is the high level things I'm telling you. Now after that, in the sixth step, we can talk about the API design. As a part of system design, this is the day zero, guys. This is day zero estimation I'm doing here. So in the API design, suppose we created a big system. Suppose this is user interacting here, and then this is the front end or something, and this is the API gateway, suppose. And from this API gateway, there are different services like those video upload. This is for the video watch. Suppose subscribe. For that, right? So see, everything is API driven, right? And again, this could be go to some storage layer, caching layer, and all. Storage, and then some caching system. So for this system, if you see, right, so for every interaction, there will be some different endpoints. Endpoint for upload. Those requests will come here. Endpoint for watch will come here. Endpoint for subscribe. Those requests will come here. So API design. So first of all, try to understand what API is. So API gives you the way to communicate between the heterogeneous system, right? This is the way, this is a language, a universal language through which we can through different different system in the sense that suppose one application is developed using the Java, some other application is the backend is developed using the Python, and some other application using the some C sharp or other language. But still, in order to make the communication happen between the API between them, it's pretty much important we are using the API. Through the API only we can make the communication happen between these three different applications or services. right? So this is the universal communication language, I would say. That is pretty much important. So we will be then writing the API for our AI system, let's say. Okay, then as a seventh part, I will be talking about the infra design. Here I will be talking about the compute in terms of the servers, VMs, right? Then there will come concept of the storage, the DB or the object storage, because there will be some information that will be storing in the S3 GCS bucket. So those storage will also come into the account, right? And some of the metadata information will be keeping inside the databases. However, the raw information on the storage, object storage, and then there is a network, right? The routing thing, and the load balancer things will come into the picture here. Then the CDN, and then I would say the security aspect, right? And many more things will come inside the infra design decision making as well. So that's it really, guys. I think I have pretty much covered each and everything as a part of today's agenda, where I talk about software development life cycle, uh, what all the steps comes under the software development life cycle, and it's pretty much important for you as a software developer to understand the importance of every steps, and accordingly you can deliver a very good high scale system, which is very performant enough as per the client need. And then we talked about the system design aspects as well, right? So seven core pillar also they I have discussed. They are like a requirement gathering, functional one, non-functional one, then the capacity planning for estimating your expenditure for the your product project or application development, projection for 1 day till 1 year till 5 year or 10 years, right? And what kind of assumption we can take into the consideration, and how we are going to calculate going ahead. These things I will going to discuss very soon. And then after capacity planning, we talked about the HLD, high level design document. Then LLD I talk about, which is nothing but the low level design document. And then I talk about the DB design, API design, infra design. And this is, I mean, this is that's it. I mean, in terms of the system design mindset, because this is system design is nothing but a approach, right? A blueprint, a mindset, a philosophy that you need to understand as a software developer in order to create any system, be it a plain, very, I mean, full scale application having front and back end only without any AI system, or it could have the AI system as well. That system also you can design, because I have given you some glimpse about the what all things comes under the rack system or AI system, right? So after going through it, you'll able to understand end-to-end story, which is pretty much important. So with that, guys, I am signing off for today, but remember, keep learning, keep growing, and keep building together. Thank you.